All right, 7.2, we're going to add, subtract, and multiply radicals. So yesterday, we just learned how to simplify them. Now we're going to add, subtract, and multiply them. Adding and subtracting is a lot like adding and subtracting variables. For example, what is 2x plus 3x? 5x. Does your x just stays x, right? You don't do anything else with that. Can you add 2x plus 3y? No, because they're different variables. Can you add 2x plus 3x squared? No, you can only add 2x and 3x. They're like terms. So that's basically how it works with radicals. You can only add if you have like square root of 3 plus a square root of 3. You can't add a square root of 3 plus a square root of 5. You can't add a square root of 3 and a fourth root of 3. They have to be the exact same root, same index. So when we're adding and subtracting, you first want to simplify all of your radicals. So let's start here with this one. 3 square root of 27. So I've got my 3. Got to break up the square root of 27. What is the largest perfect square that goes into 27? 9 times what? 3. So this is 3 times, what's the square root of 9? 3 square root of 3, which is 9 square root of 3. On these, you don't need to worry about putting a plus or minus. If it's a question where I want you to include that, I'll have that in the directions. Like I would say, include the plus or minus sign when necessary or something like that. But you don't need to worry about that here. And then we have this. Negative 2 times the square root of 12, which we need to split up. What is the largest perfect square that goes into 12? 4 and 3. 4 times 3. So this is negative 2 times 2 square root of 3, which is negative 4 square root of 3. So because both of those are square root of 3, we can subtract them. So 9 square root of 3 minus 4 square root of 3 is 5 square root of 3. Okay. Now we're going to number 2. These are cube roots. So we've got this first one, 3, and then my cube roots. What is the largest perfect cube that goes into 54? 27 times 2. So this is 3 times, what's the cube root of 27? 3 cube root of 2, which is 9 cube root of 2. Now this next one, can I simplify the cube root of 2 down anymore? Now there's no cube roots that go into 2, so I'm just going to bring down my minus 2 cube root of 2. And then I've got this one, 7, and then my cube roots. What is the largest perfect cube that goes into negative 16? It is 8, but always put your negative with your perfect cube. So negative 8 and 2. What's the cube root of negative 8? Negative 2. Cube root of 2. So this will be minus 14 cube root of 2. And notice how all of these are cube root of 2. So you can add or subtract those. So basically you've got 9 minus 2, which is 7, minus 14, which is negative 7 cube root of 2. Any questions so far? All right. Number 3. Got 7. We have these fourth roots. What is the largest perfect fourth that goes into 48? 16 times 3. So this would be 7 times 2, fourth root of 3, which is 14, fourth root of 3. Now this next one, that's a fourth root of 3. That doesn't simplify at all, so just bring it down. And then this last one. What do you notice about this last one? It's a cube root, so we still have to simplify it, but there's no way that it will be combined with these two at all. So that's something you've got to really be careful with in this unit is pay attention to that index. What is the largest perfect cube that goes into 72? 8 times 9. So we get 3 times 2, which is 6 cube root of 9. So we can combine these two. 14 minus 2 is 12, fourth root of 3, and then I just have plus 6 cube root of 9. Just like that. See if you can do number 4 on your own. Okay. The first one, 10 radical 28, should have simplified to 20 square root of 7. And then the next one simplified to minus 2 cube root of 7. And the last one simplified to negative 20 square root of 7. And those two end up canceling out. 20 minus 20 is 0. So you just have negative 2 cube root of 7 left. Are there any questions on these? All right. Now we're going to get into multiplying. So when we multiply radicals, we start with multiplying the coefficients, the numbers out front. And then for what's under the radical, we use the property rule. So if I have 2 of the same index, so you can only multiply square roots by square roots, cube roots by cube roots. If you're multiplying those, you get that index, and then you just multiply what's under the square root. And then you simplify. If you have fairly large numbers to begin with, sometimes it's a little easier to simplify first and then multiply and then simplify again. Just because when you're working with big numbers, sometimes it's harder to find those perfect squares that go into it. And I'm talking like numbers in the thousands that you could possibly see. So number 5, we're working with fairly small numbers here, so we won't simplify to begin with. So there's no numbers outside to multiply. So we're just going to use the square root of 27 times 5. So we've got the square root of 135. And then you just split that apart. You want to find the largest perfect square that goes into 135. Who's got that? See, anybody found it? It's 9 times 15. And the square root of 9 is 3. Bring down the square root of 15. Number 6, we multiply the numbers outside, and that's negative 6. And you multiply the numbers inside. What's 10 times 18? 180.
Do you not bring that negative, the outside negative, just with the outside number?
Yeah. Yes. And so this is negative 6 times some square roots. What's the largest perfect square that goes into 180? It is 36 times 5. So this is negative 6 times 6 square root of 5, which is negative 36 square root of 5. Any questions? Not too bad, right? So number 7, here we're working with cube roots. So just always be aware and be looking for what your index is, because that's something that'll trick you if you're not paying attention. So this is 2 times 5. I didn't need to write that 2 yet. 2 times 5 is 10. So we would have 10 cube root of, what's 9 times negative 24? Negative 216. Know anything about 216? It's a perfect cube. I know this might, you probably can recognize perfect squares pretty easy. You should be kind of not necessarily memorizing your perfect cubes, but if you see a number, you should kind of say, I think that's a perfect cube. Because when it's a perfect cube, you don't need to split it apart. Okay, so if you can try to get used to seeing those numbers, that'll make this a lot easier. If you can recognize if they're perfect cubes or not, that'll make this process faster. So what is the cube root of negative 216? Negative 6. So this is just 10 times negative 6, which is negative 60. Number 8, we've got negative 3 times negative 1, which is positive 3. Fourth root of what? 512. Okay. What is the largest perfect fourth that goes into 512? 512 is a perfect cube, but it's not a perfect fourth. And we're doing the fourth root. 256. 256 times 2. So if you want to keep a list of your squares, cubes, and fourths on each page, that might be helpful. So this is 3 times 4, fourth root of 2, which is 12. I don't know why I put a 3 there. Fourth root of 2. Questions? Gonna throw in some variables. Back to square roots here. So we have a 5 outside, nothing to multiply by, so just bring down your 5. And we have 48 x to the 9th. Remember, when you multiply variables, you add the exponents. What is the largest perfect square that goes into 48? 16 times 3. Is x to the 9th a perfect square? It has to be a multiple. 9 is a perfect square, but be careful. For variables to be perfect squares, that exponent needs to be a multiple of 2. So it's not a perfect square. So how many x's do I need to bring over here to make it a perfect square? Just one x. And then we're left with x to the 8th. So this is 5 times 4 x to the 4th. Square root of 3x. Good. So it's 20x to the 4th, square root of 3x. And I really should have done better here. I should have put a multiplication symbol there or an extra space because that almost looks like the 4th root. So be very cautious and make sure you're writing neat. Number 10, cube root. Nothing on the outside to multiply. So we've got 54 times 5, which is 270, x to the 12th. What is the largest perfect cube that goes into 270? 27 times 10. And then x to the 12th, is that a perfect cube? Yes, because the 12 is divisible by 3, so the entire thing stays on the left side. So this is 3x to the 4th. We're dividing by 3. Cube root of 10. Questions so far? All right, now we got 4 more to go. Number 11, we're going to use the distributive property to multiply. So we're multiplying each of these by the square root of 10. So the first one, when I multiply by the square root of 10, I would get 5 square root of 50 minus 2 square root of 20. Questions on that? So this is 5 square root of 25 square root of 2 minus 2 square root of 4 square root of 5. So I'll just split the 50 into 25 and 2 and the 20 into 4 and 5. Square root of 25 is 5, square root of 4 is 2. This would be 25 square root of 2 minus 4 square root of 5. And that's your final answer. Since your number under the square root is different, you can't do anything else with those two. Number 12, we have a binomial times a binomial. So this is, you could do FOIL method. I'm going to draw a box just because I like that myself. I think it helps you not miss anything. So we have a 2 by 2 box, and I like to make it wider so I can write more in there. What is 8 times 3? 24. And then 8 times negative square root of 10 is negative 8 square root of 10. And 3 times negative square root of 10 is negative 3 square root of 10. So this one, negative times negative is positive, and then we have square root of 100. What is the square root of 100? 10. So that equals 10. So then my answer, these are like terms. 24 plus 10 is 34. Minus, these are like terms because they're both square root of 10. So minus 11 square root of 10. If you only have one root in your answer, it's better to put that second. It's not wrong if you put it first, but usually you'll see your answers written like this. Not always, but usually. Number 13. I'm going to draw a box. Made this one a little bit too small. 6 square root of 6, negative 6 square root of 2, square root of 6, square root of 2. This first box, when I multiply the outside numbers, that's just 6 square root of 36. I don't have enough room. I didn't leave enough room to simplify that, so I'll have to do it down here. This one, I would have 6 square root of 12 What is this one? Yep. And then over here, I have negative 6 square root of 4. I have a 6 square root of 12 and a negative 6 square root of 12. What happens there? Those cancel. And so 6 square root of 36 is really just 6 times 6, right? Minus 6 times 2. 36 minus 12, which is 24. What does it mean when you have a binomial squared? You're going to have to do FOIL or the box. Got to make sure you write it out like this. You don't just square the first term and square the second term. Yes, you can use the box. All right, so if we do the box, four minus radical 5, 4 minus radical 5. See if you can finish this one. All right, you should get 16. And then these two are both negative 4 square root of 5. Those don't cancel. You need a positive and a negative for them to cancel. Because negative 4 and negative 4 makes negative 8 square root of 5. And then this, you get positive square root of 25, which is 5. So that's where I get the 21. The 16 and 5 make 21 minus 8 square root of 5. Are there any questions?